Lieutenant Dan, is that you? Hey, anybody know what movie that's from? Well, if you do, you should let me know next time you see me. But you are a lieutenant right now in level 6 of Solving Equations Boot Camp. And I'm going to try to help you move up to the ranks of level 7. Uh, but this level is all about solving equations with variables on both sides. This is the first time we will have variables on both sides of the equal sign, and we're going to have to figure out what to do to solve it. So our learning target, um, I want to focus on 2 success criteria. The first one, use inverse operations to get the variables to one side. So we can't solve these things unless we get the variable to one side. But then the other one is kind of a bunch of steps in one. If you look back at your notes from the last level, follow those logical steps to solve the rest. So there might be something else going on. There might be it really should be a 2-step equation after we get the variables to the same side. But kind of like in the last one, distributing and combining like terms are always going to happen first. But that's what we're going to talk about next. So the only like term or the only vocabulary term for today I want to talk about is identity. And just a refresher for identity, this is something definitely to write down. No matter what you do to an equation, so adding to both sides, subtract, whatever inverse operations you do, distributing, whatever it is, if identity says that both sides are identical, okay? So we're gonna see some example, or at least one example of when that is going to happen. That's one of those a special case. But let's just say we have this equation right here. 6r plus 7 equals 13 plus 7r. All right. If you look here, we've got no distributing to do, no combining of like terms, because the left side, you can't combine these. The right side, you can't combine those. So there's no combining of like terms to do here. But what are we going to do first to solve? Because we have a variable term on the left and on the right side of the equation, which again, you can't combine those because they're on different sides of the equation. But we don't want them on different sides of the equation because that messes up every other thing we've learned. So our first step has to be to get them to the same side. So here's my suggestion. Look for whichever one is smaller. So 6r would be smaller. And 6r is just added to the 7 there. So what's the inverse operation of a positive 6r added to it? If we want to get rid of the whole 6r, it would be subtracting 6r. Okay? You might think we're going to divide, but again, if we divide, that only gets rid of the number in front of the variable. We want to get rid of the whole thing. So to get rid of the whole thing, it's a whole term. We want to subtract it from that side, but we have to subtract to the right side as well. So we bring down what's left over, and what's left over on the left side is just a 7, and on the right side is 13 plus 1r, or just r. Now we have a 2-step equation, and the variable is all by itself, or it's all just on one side, which is a very good thing. So if we're following our steps, our logical steps next, we're going to get rid of what's not attached to the variable. So this would be a 13 because we're looking on this right side, and we're going to subtract 13 and do that to the left side as well. All right. Bring down what's left over. We have 1r equals negative 6. Now 1r is the same as r, or if we divide by 1, that'll show the same thing. But we end up with negative 6 equals r. Or in other words, r equals negative 6. So you can write it either way. Now, how can we write that in a procedure? Well, here I've got one for you. Exactly what we just did in step by step. So write down this procedure here. Our first step was to use the distributive property or combine like terms if they're on the same side, if needed. In this case, it wasn't needed. We couldn't do anything. There's nothing to distribute, nothing to combine. So we skipped down to step 2. Undo the variable term on one side to get the variables to only one side. And my tip there for you was to look for the smallest variable term. That's why we started with that 6r, and we got rid of that by subtracting on both sides. Step 3, then solve it like a normal 2-step equation. So that could be 2 steps there. And finally, check your answer. So if we check it and plug back in our negative 6, we'd have on the left side, negative 6 times 6 would be negative 36, plus 7 would be negative 29. And on the right side, 7 times negative 6 would be negative 42, plus 13 would also be negative 29. All right, and you can write that down if that helps. I want to go through two other equations before I give you some practice. And these two are actually going to be special situations. We're going to solve them using those exact same steps, but you'll notice something weird is going to happen. So if I look for the one on the left, so our second example here, we'll say example 2, and this will be example 3. If I follow the steps and I try to look for any distributing or combining like terms, there's nothing I can do on either side. So then I move on to getting rid of the variable from one side. They're both 7, so neither one is smaller. So let's just pick this one. I'm going to subtract 7 from here, 7a, to get rid of that whole thing. So I can get rid of it from one side, and there's just a 4 left over there. And now I'm going to subtract 7a here. What happens when I do 7a minus 7a? It cancels out here too. That's just 0. So what I'm left with in this is negative 3 equals 4. So then I say, what? Question mark, question mark, question mark. What in the world just happened? I look at that and I say, there's no variable left, so how am I supposed to even solve for a variable? I also look at that and say, well, negative 3 does not equal 4. So this is a unique situation where our answer is that there is no solution. In other words, there is no letter, no variable, or no number for the variable a that could make this work. It's impossible to solve. So there is no solution. And the reason we knew that was two things. Variables canceled out on both sides. So I'm going to write that down. On both sides. And the second thing was that the two sides were not equal. Let's look at the second example. See what's unique about this one. So if I take this one and I say I want to get rid of the smaller term, again, same idea, because there's no distributing or like terms to do. They're the same again. So if I add 6a to get rid of this negative 6a, and I add 6a here, once again, a negative 6a and a positive 6a cancel out. So I'm left with 3 equals 3. So what does that mean? Well, this time, does 3 equal 3? Yes, it does. This is called an identity. So in our vocabulary for today, we had the word identity. An identity is when you end up with exactly the same thing on both sides. So if I looked at the original equation, it was negative 6a plus 3, and if you just switched it around, it was negative 6a plus 3. They're identical on both sides. And when you get rid of the variable, you can see it even clearer. 3 equals 3. It's the same. So key points to know if it's an identity is variable canceled out on both sides again. And this time the two sides are equal. That's an identity. So these are three different types of equations with variables on both sides. One is a normal one, where you have to get the variable off one side, so it's just on the other side, and you can solve it then normally. And these two are unique ones where when you get rid of the variable from one side, it also cancels out on the other side, and you're left with a unique situation. So what I'm going to give you is two examples, and I'm going to have you pause it here, and I want you to try them. The first one is just a straight up equation. The second one, you're going to have to write out the equation from what the term words are, and then solve it. So why don't you pause it here, try to solve them, and then you can unpause them in a minute to check your work and answers. All right, so welcome back. This first equation, there was no distributing, no combining like terms to do on either side. So what I did was try to get rid of the variable from one side. I've got a negative 4d on the left. I've got a minus or negative 2d on the right. So the smaller one is technically the negative 4d. So what I did was the inverse operation there. I added 4d on both sides. Okay, that's what was the step right here. And I'm left with just -5 on the left side, because that symbol has to stay with it. So that's a -5 equals -1 plus 2d. So how did I get plus 2d? Well, I looked right here. It was a -2d plus 4d. So that symbol always stays with what it's in front of. All right, now I'm at this step. Now I'm going to add 1 to both sides because I want to cancel out this plus 1 that's on the same side as the variable. And I end up with -4 equals 2d. And finally, when I divide by 2 to get the d by itself, I end up with d is equal to -2. All right, now number 10, this bottom one, it says the product of 4 and y. So that's multiplying 4 times y. Increased by 5, that would be plus 5. I'm left with 4y plus 5 is equal to, so I've got an equal sign here, the sum of y and 8. Sum is addition as well. So my equation that I make is right here. Now it says find y. So I moved it down here so I can solve it. I took 4y plus 5 equals y plus 8. I put a 1 in front of the y here. And since that's a smaller y term and it's on the right side, I'm going to subtract it from that right side to cancel it out, and then I subtract it from the left side. So I'm left with 3y plus 5 equals 8. I'm right here now. So I subtract 5 because that's the term that's not attached to the y. Do that on both sides, and I end up with 3y equals 3. And divide by 3 to get y equals 1. That is our answer. So that's what we got for variables on both sides. Again, our learning target was to simply solve equations with variables on both sides. The one thing that we didn't really do was any of these where there's distributing or combining like terms, but that's going to be coming in the next level. So the next level will add a little challenge to you that way. Hope you learned something in level 6. Hope you can move on up the ranks past lieutenant soon enough. We'll talk to you later.